I created this talk for Lightfair 2023. The topic is Artistic Illumination of Clothing, Costumes, and Accessories. I'm recording a copy for people that were not able to attend in person. My name is Janet Hansen. I'm an LED artist and I specialize in mounting lights in fabric. I have a lighted clothing company called Enlighted Designs, and I have a separate website for my fine art portfolio. I'm based in Encinitas, California, which is near San Diego, and I've been doing this for more than 25 years. Here are some examples of things that I've made in the past. There's a huge range of effects that you can get with wearable lights. Most of my clients are in the entertainment industry. I also do some high-end party clothes and some formal wear. Here's a quick outline of the talk. I will start with a checklist of good questions to ask at the beginning of a project, and then I will cover some materials on the electronic side. That means talking about what light sources make the most sense, and on the clothing side, there are some garments and fabrics that are better to work with. I also have some case studies that I'll go into in more detail. So to start a project, I like to make a list of all of the visual requirements and be as detailed as possible. And this will be helpful whether you're the one that's building it or if you need to explain what you need to someone else. So the visual requirements would be, what does it look like by itself and what kind of lighting effect are we adding to it? Do you need a certain color? Do you need a certain kind of change in the effect? If the lights are changing, do they all do this together, or do we need independent control over each light? And in this example, when the lights are off, the dress does not look like it has anything that has been modified on it. And then when it lights up, the rainbows move down with each light controlled independently. It's also helpful if you can explain your artistic requirements, and this would be answering the question, why are we putting lights in this thing? There are a lot of reasons. Maybe it's for a fashion statement. Maybe you want to use the lights to do something interactive, or maybe it's an important part of a performance, say explaining who a character is, showing where you are, doing something to emphasize the plot point. And the reason it's good to understand why this is being done is because a lot of requests I get are going to be very impractical or maybe impossible, and if I know why we're doing it, then I can often recommend a good alternative. There will also be practical requirements, and these are things like, how long do you want your batteries to last, how much space do we have to hide these batteries, and how much light output do we need, and that there will be a trade-off between those top three items. Also, if it's going to be controlled with manual switches, do the switches need to go in a specific place? If it will have wireless control, where are we going to put that? So this example is a lighted dress that I made for a Britney Spears tour, and the lights on the front do two different effects. One I would call fireball, and the other one looks a bit more like lightning. And the production team wanted to control this wirelessly so they could trigger them at very specific points in the song. We did not need very long battery life because this was worn just for the last song, but there also wasn't a lot of space. So in this case, we ended up making compartments in the backs of the shoulder pads for those parts. Some other practical requirements are things like, how will it be used and how much use will it get? If it's going to get a lot of use, then we probably need to figure out how to clean it. So this project for the Rockettes was pushing the limits in a lot of ways, very intensive dancing. It was used for a few months in a spring-summer show for a few years in a row. And yes, they did want to be able to wash these. So for them, we developed a method where all of the lights could be removed. As you see them, they're crystal-topped studs above each light that are mounted in buttonholes, and you could unzip the lining to take them all out and dry clean the jacket and then put them all back in. Though to put the lights in the right order, this took maybe a little more than an hour per jacket, so this is not going to be practical for everyone, but in this case it made sense. For lights that need to be in a fixed position and we don't want to rearrange them, then it's usually going to be better to have a lining in the jacket that can be removed and you just wash that part, or maybe you have another garment worn underneath it. So the batteries, the controller are usually not going to be washable. And even if the lights are waterproof, the twisting and pulling that can happen in bulk processing is usually what's worst for them. So a lot of these will just be spot clean only. Sometimes the biggest practical constraints are going to be the budget and the schedule. So making custom sewn pieces and custom electronics can really add to the cost. So if you need to cut back on that, the more off-the-shelf pieces you can use, the more that would help. Also, it's possible you might not need to put lights on the whole thing. In this example, the outer fur coat part is full of lights, but the rest of the bodysuit is reacting to bright UV sources. And sometimes a hybrid effect like that might make more sense. Then there are also going to be requirements that people might not ask for explicitly, but they are definitely implied and they are important. So the lights need to be reliable and durable enough to survive whatever conditions you're expecting, especially if this is going to be dancing on live TV, like the example in the middle. You also want the lights to be comfortable so that you can move naturally and you don't look too stiff, unless maybe you are actually wearing a knight's costume. And the other thing that will make you uncomfortable is if you have some kind of sketchy electronics in your underwear or somewhere else close to your body to a point where you do not feel safe. So it is really important to think about safety in these projects. At the very least, you don't want to cause electrical shocks or overheating or eye damage from crazy bright light sources. And the list will be longer depending on how you're using it, but it's just very important to take this seriously. And the better foundation that you can set up, both in taking care of safety and the practical requirements, the more fun you can have with building on the artistic part of the project. So next, I'll be talking about the light sources that make the most sense for these projects. And here it's helpful to understand the strengths and the limitations of each kind so that you can make better choices. It was not that long ago that we really did not have much of a choice at all. If you were wearing some kind of lighted costume in the 1970s or 80s, you were most likely wearing strings of incandescent lights. And as you know, these can get really hot and are difficult to work with because of that. And you also really only get one color unless you paint or tint the bulbs. So to do a color changing effect, you would need multiple sections of lights that could be controlled separately. So as LEDs became more available and more affordable, they were very quickly a better choice for wearable projects. The low power versions are cool to the touch. They come in a lot of form factors and colors, and even better, you can put multiple colors inside the same lens. So a lot of my earlier projects were like these old school bicolor LEDs, where you can get red from one side, green from the other, or yellow if you light them up together. So I was really excited when blue LEDs and then RGB LEDs came out, which is basically the same thing, but adding blue means you theoretically can get any color you want out of this lens. This is the through-hole version, and this is the surface mount version. This was also not very long ago. It wasn't until about 2000 that blue and RGB LEDs were about the same order of magnitude in terms of cost as the earlier red and green ones. I will be talking about this a lot more in the talk, but first I want to step over to some of the other lighted options for clothes. Electroluminescent or EL wire is popular. It looks a little bit like neon, but it is not nearly as bright, so it really needs to be used in a dark room. It comes in multiple colors that you get from the internal phosphor and a plastic coating, but you can't change colors unless you put multiple lines of this next to each other. You can flex it into nice tight shapes, but it is not designed to be flexed over and over and over again, as would happen if your body is dancing or moving a lot. Every single movement will flex this wire. So you need to keep these limitations in mind if you're using it. One project that I did, this one for the MIA's backup dancers at Coachella, the room was dark enough, and we didn't really need to worry about durability because we knew it was only going to be used for one show. If you see other dance troupes that are using this type of lighting, most likely they have the EL wire mounted on some kind of reinforced surface instead of directly on the clothes, or they might have some kind of ongoing maintenance schedule that the audience just doesn't know about. This other project that I did for Daft Punk, they understood that it was very fragile and handled it well enough that it could last for a world tour that lasted more than a year. Like, this was the kind of outfit you're not allowed to sit down in to be durable enough. And also, to get the brightness that they wanted, it was necessary to overdrive the EL by quite a bit and to get power by plugging them in to the DJ booth. So I've had a lot of fans reach out saying they're very excited, they want an outfit like this and go out clubbing all night, and have to break the bad news that that's just not really practical with this kind of lighting. Another way you can get light up lines is with fiber optics with LEDs at the end. These also aren't going to be super bright, and this example with the fiber optic fabric, the light source and the cut ends will be a lot brighter than the effect in the middle of the fabric, so you'll need to cover those out with blackout fabric to do those. You can make fiber optics brighter by using a brighter light source, but eventually you will need some kind of protection from the heat. So here's an example of a fiber optic whip that you can buy, and as long as you can fit, the source into your garment somewhere, this can be an easy way to add some lights to something. And if you use a really bright illuminator, you can get an even brighter line. There is a product called laser wire, and it is basically a special type of fiber optic with a laser interfaced at one or both ends. And it's quite a bit more expensive because of the laser, but you can definitely see it, and it comes in red, blue, green, and white. You can also just use lasers directly on a costume, but if you do this, you need to keep in mind that once you put it on a moving body, like on someone's arm or hand or even their head, you can't control whose eyes are going to see the laser directly. So you need to use lasers where the power is low enough so that this is safe, or you can also add beam splitting optics like I have on the ends of these lasers on the fingertips on these gloves. Coming back to LEDs, where we left off, I was talking about how excited I was that we could do multiple colors within the same lens. You can also put a small chip inside there that will do an animation effect. So here is an example with an orange flicker, and here is another one where the colors are fading between red, green, and blue. And this is the way a lot of LED candles work. You can also get these LEDs separately and use them as a shortcut to putting an animated effect in a costume without needing a driver. You just need to hook it up to power. So if you do want to control each LED separately, you will need a dedicated driver with green, red, and blue outputs. And you can do this for a single LED or for a group of them, like this, though they'll all be the same color. If you want different sections of the costume to have different colors, then you're going to need another set of 3 outputs for each of those. So very quickly we outgrow what is possible to do reasonably with a parallel style circuit. And that's when we jump to a serial communication strategy. And here we can have all the LEDs in the same chain. There will be power and ground passed along, also a data signal, and some types use a clock signal. And each of these pixels can be a different color, but it needs to be smart enough to interpret the data stream and figure out which instructions apply to it. So there's a lot of extra circuitry on both the top and the back of these pixels. This is the approach that was used to do the lights on this Britney Spears dress. Here's a close-up of the path weaving around. And because this was 2011, you had to make your own pixels if you wanted something that could do this effect in miniature on a costume. And this took a lot of engineering, very expensive, and all the people that were doing this kind of work were using their own personal protocol. There wasn't really a lot of sharing that was possible. So the big breakthrough that came through around 2012 was the release of the WS2811 chip. And this is a dedicated RGB LED driver that handles all the processing of the signal. And you just have to attach your own LED to it for the RG and the B part. And when this happened, it meant a lot of people could use the same type of pixel. The cost of that came down, and a lot more people worked on controllers and software that could be shared between different people working with these lights. And then, even better, this chip was miniaturized to the point where it could be put inside the LED itself. And this looks like an RGB LED, but the 4 pads instead are power ground, signal in and signal out. The most common one is called the 2812B or Neopixel with some vendors, but there are dozens and dozens of versions of these out now. Some of them are RGB white, some have a faster refresh rate, but the Neopixel is the most popular, so it's also usually the least expensive. You can get it in a lot of different form factors, attached to panels, boards, strips, even individual pixels like this, which I've wired into strings by myself. Even within all these options, some of them will be better for certain kinds of clothes than others. So here, pixels on tape and rigid boards aren't going to work on something that flexes or stretches a lot. That would usually go on a more reinforced thing. And there is a type of fairy lights that has a solid core wire between them, and those are not intended to flex constantly, so there will also be limits on when this is the better choice. So what you want to do is use it for best durability and most versatility. I would recommend individual pixels joined by stranded wire with insulation and with a good amount of strain relief at the edge between the pixel and the wire. So this is a type of pre-wired string you can get that has a little plastic case around it. Here are some handmade versions I've done with epoxy to make them waterproof. And here is a new pixel type that's just come out in the past year. And here, this is the LED embedded in a little epoxy blob. So these can get quite small. Now, to make these do what you want to do, they have to be hooked up to a driver that speaks the right language for them. And that would take way too much time to finish in a short talk like this. So here are some resources where you can learn more about the drivers. Adafruit and Spark Fun both have good tutorials for parts that they sell. You might find tutorials on other parts of the internet that might be good or not good. And Pixel Blaze is a good platform if you want to get into the coding of the patterns itself. And this list also has some good resources. So switches, most of the things I make will have two kinds of switches. There will be an on-off switch in between the power source and the controller, and then some momentary switches that I use to change the pattern or the brightness or things like that. And whatever you use for the on-off switch, it's important that the switch can handle the amount of power, the current and the voltage for the whole outfit basically, which can be a couple of amps. So please keep that in mind and pay attention to the ratings, which will be written on a lot of switches. So this little tiny switch might be cute, but it's probably only rated for about 100 milliamps and will not work for a costume with lots of lights in it. The power limits are not as important for momentary switches since all the power is not passing through those. Then with switches, your main priorities usually are you don't want it to be too easy to press accidentally, and you also don't want it to be too hard to press. So to prevent it from being hit accidentally, sometimes I will use switches with a bezel, or in this case, a hinge door for extreme cases. And we also don't want it to be too hard to press the switch. So think of a toggle switch or a rocker switch like this. If it's just hanging at the hem of a garment, it might be hard to trigger it without having anything you can get leverage against. Or maybe you need to use a second hand, and that will look awkward. So in those cases, I often mount a switch on a small circuit board so that you will have enough leverage to grip it and flip it with just one hand. And then this would be covered with fabric and mounted inside the garment somewhere. Batteries. The cheapest, easiest way is usually going to be packs like this, where you can pick the number of AA's you want for your voltage. Some of them have a nice cover, though the drawback is these springs here. If you really whack this hard or someone's jumping around again, an individual battery can bounce enough to reset the power, and depending on the type of driver you're using, that might look bad. So to avoid this problem, a sealed battery pack is popular. You can use a USB power bank if you want 5 volts and a low enough current. A lot of my projects have higher voltages and draw a lot more current, so I tend to use this type of battery pack from the RC hobbyist industry. And these come in lots of different voltages and sizes also. I prefer the nickel metal hydride type of rechargeable because it's one of the safest and it doesn't have a memory effect for recharging. For really small stuff, I tend to use a lithium-ion 9-volt like this, or lithium coin cells, and the key feature of these is that they have a hard metal case, which is important for safety. I definitely do not recommend a lithium polymer cell with a flexible case around it, because if you pierce this, the whole thing can catch on fire, and that's going to be sad enough if it happens to your drone. You really don't want that to happen to something that's in your pocket or close to your body. So a quick recap of some of the safety points from the electronics section. The batteries are the most dangerous part of your system, so don't do anything that makes that worse. I recommend using insulated wire and cover all of the connections so there's nothing exposed. You want to use large enough gauge wire and switches, regulators, and other components that are rated for the voltage and current going through them. And to avoid overheating, there are pixels that do generate quite a bit of heat. You can get a 3-watt version of a pixel that looks kind of like this. And for this project, they wanted very, very bright bursts of light occasionally. So these are some silicone heat barriers that I built with a kitchen mat. Also, you don't need to run everything on the brightest setting possible. That's going to drain your batteries really fast and create heat that can be uncomfortable for the person wearing it. So that's another thing to keep in mind. And finally, if you're using lasers or really bright UV sources, please do that responsibly so you don't damage anyone's eyes. Moving on to the sewn parts. Generally, the types of garments I prefer to work with are going to be outerwear. These are usually made of a non-stretch fabric that has enough structure to support some lighting. There are natural places to put pockets for batteries. A lot of them will have a lining already. Again, is good for hiding wires between the outer and inner layers of fabric. And people also don't really expect to wash their outerwear as frequently. So that's better for things that are hard to wash. And t-shirts are pretty much the opposite of all of those things, so I don't do a lot of work with t-shirts. Another type of garment that can be relatively easy to work with is something that has a lot of internal volume between the body and the outer layer of fabric. So a dress like this, you can have pockets hanging from the waistband to put batteries, controllers, and whatever you want. Small pieces also can be harder to work with. This top hat has a pretty good amount of space, but all the rest of these things are powered with 9-volt batteries, either on the back, like this tie, here, the center back, or at the top of these boots. And if the item is really small, then it's usually going to be necessary to run wires to somewhere else on the body and hide the controller and the battery there. It can also be hard to work with something that's really thin, stretchy, and tight, partly because there will be a big lump where you hide the battery pack. In all of these costumes, it's on the back. And to make the electronics work with this amount of stretch, I use individual pixels, and there is a generous S-curve of wire following this whole path, so that if you stretch the fabric in any direction, the wire is never extended completely straight out. Another strategy you can use is to make some parts of the costume just non-stretch and put the lights there, and the stretch is taken in by the rest of the fabric. And in this example here, if you want to have lights behind something very sheer and flowy, but it's so thin that you don't want the weight of the electronics to make it sag wherever you have a stitch, then I would recommend using a separate layer that the lights are attached to, and then you can just have the thinner layer floating in front of it, which is what I did here. You can make more stable bases to mount the lights on by using athletic pads. Here are some costumes that use lacrosse pads mostly. So this one is an example of a way you can mount EL where it will be protected from flexing. So in this next section, I'll be showing some different mounting techniques that change the appearance of the lights. And one strategy is to just have them completely exposed, and that was the intentional design choice that was made in this collaboration. We wanted the person viewing it to be able to see this is how these lights work. Though in a lot of cases, you might want it to be a surprise when you turn the lights on, so it's more common for me to cover the electronics. So here is an example where they're covered with a sheer layer, which mostly keeps you from seeing the wires, but it's thin enough that you can see the light shining through here. If your fabric has some kind of embroidered design on the outside or other embellishment that you don't want to cover up, then it will make more sense to make holes in the garment and mount the lights behind that so the wires are hidden by the fabric itself. This page shows a few examples of mounting things in holes. Depending on the pixel you're using, you might be able to fit it in a rubber grommet. Sometimes I just cut the holes directly and mount it from behind with glue. Or if your textile has a really loose weave, you can just poke the lights through without even cutting anything. So that's what I did in this flip sequin fabric. Has gaps you can use for that. Here are a whole bunch of fabrics that you can use to conceal lights that are mounted on the outside. So some of them will have stretch, some are non-stretch, and notice here you can see the distinct points of light. Here they're a bit more diffused. I use a lot of polyester fiberfill, and here you can control the amount of diffusion by the thickness or the number of layers you use. And basically this is just enforcing the distance between the LED and the top layer of fabric. Faux fur is also a really good diffuser. Here's an example where it looks like the whole surface is filled in, and these lights have about 5 centimeters spacing throughout. Every now and then I'll get a request from someone who really likes a white coat that I've made, and they say they want to see the exact same thing but in black. And I finally have this example picture that I can show them that it's not really going to work. The dark fur will just block the light too much. Even if you use a short pile fur, it's just not going to travel sideways the way it does in this white fur. So if you're working with a combination of fabric and lights that you haven't really used much before, I'd recommend making a mock-up or holding the lights next to the fabric to get a sense of whether it's even going to look good. Here's another example for these costumes. The client wanted diffused shapes that were done with plastic molded pieces, and we learned pretty quickly that a textured plastic just was not going to diffuse it enough if it was clear, so we had to use a frost spray to make it more uniform. Another technique I use is making a stencil in the outer layer of fabric. And here's the base layer with the LEDs doing the S-curve again, so this is very durable, flexing in any direction. And here's a window covering it up. If it's just organza, you see points of light, and if you add a little bit of the diffusing material, then you get this uniform rectangle or stripe shape. And I use this a lot to do names, logos, and designs like this. So that brings us to the case studies. I have one that talks about a bunch of different fabric treatments, and the second one is an example of performance with a lot of other types of constraints. So this one is a project that I did for Madame Tussauds Glow Gala at their New York City Times Square location. It was installed last year, and it's still on exhibit now. If you have a chance, you can go see it in person. And the goal here was to decorate the room to look like an exclusive rooftop after party. And everyone is wearing something inspired by a red carpet look, except we have added lights to some of the dresses. And the goal here was to have a background effect that the lights would do, but then periodically they would do a show that was synchronized with a multimedia experience in the rest of the room. We did not have to worry that the wax figures were going to be dancing, so we didn't have those durability concerns, but the guests are encouraged to pose for selfies, so they had to be durable enough for that kind of interaction. And because these are in fixed positions, we were able to use wired power and data, which was helpful. The centerpiece is this Katy Perry chandelier up here, which is inspired by a dress she wore in 2019. And here they decided, well, let's make it into an actual literal chandelier. Here is a close-up of it. To make the dress part look like the glass of a chandelier fixture, I've created a textile with rows of clear beads, and this is the type of pixel mounted behind it to get this effect. And the Lady Gaga dress, the lights are diffused by very large organza ruffles. Here is a picture of the shirt under construction. It was not a stretch fabric, but I still used this S-curve. You see the star effect we get with a gap between the lights and the organza, and as layers of organza were added, it eventually covered up the wires. And here's an example of a pocket hanging from the waist of a big skirt, and we put the controller here. There are a lot of plugs because this is divided up into zones to make it possible to dress and also for power distribution. This video shows test mode, looking at the pixel mapping for the skirt before the organza layer was added. So we were also looking at different sizes of ruffles to decide what to use. This is a schematic of the pixel layout, and to give them fairly uniform spacing, I used a radial pattern, so the wires go here, and then there's a jumper in here, and it jumps to this, and so on. And again, this is repeated in a couple different zones, and I used the slightly bigger type of pixel here so that they are probably okay if someone steps on them just a little bit. This is the outfit that I did for RuPaul. It's a dress and wings inspired by a classic Bob Mackie outfit. And here I used this type of pixel, and they were first hand sewn onto the silver base dress and then covered with this mini sequin fabric, and then layers and layers of extra sequins were added in between. Here is a demo that shows the pixel mapping effects on it. And because we don't have a big skirt covering up the floor, we needed to hide the controller on the back. So this is sort of a backpack structure with supports for the wings, and the whole thing could be laced into the corset. This dress for Priyanka Chopra has several types of lights. Behind all the feathers, I'm using this kind of pixel, and it's been programmed so the colors in the lights match the color of the feathers most of the time. In the crown, this is one use case where this kind of fairy lights is a good choice, because the copper can be wrapped tightly, but you're not going to keep bending it over and over again. And to light up the bodice, they wanted lights following these lines of silver trim. Here is a close-up of this with the lights mounted on top of the silver trim, and then they poke through gaps in the braid and look like this. This project for Rihanna is the dress is inspired by something she wore, also covered with lots of pearls, and to make the LEDs poking through these holes look a little more like that, we tried a bunch of different types of lenses, and these are all glued above the LED to give it a dome shape. So my last case study is something that I did for Christy Sellers on America's Got Talent. She was on it last year and ended up finishing in second place overall. And her style of performance is a combination of very athletic and artistic pole dancing, with a video playing behind her that she interacts with to tell a story. And I've worked with her on some lighted costumes and props in the past. So for this one, she needed something that would look good on TV, have very high durability. We had to fit a lot of electronics in a small space. And she wanted, to match the choreography, she wanted a few types of effects, mostly gold twinkling, and then bursts of different colors at specific points. And for this, we have one switch that she presses to start the sequence, and then the timing is programmed to match the song, so she only has to hit this cue once. She also wanted to do an effect at the very end where the lights would shrink to the center of her chest, and she could make it look like she was pulling one light out and handing it to the judges. And this was all done with a very fast turnaround time of about a week. This is what the costume looks like when it's off, and here it is with a close-up. This is one of the LEDs, and here's another one. You can see they blend in with these gemstones. So to mount it, I had to separate this decoration from the internal part, and had to keep track of the path so the pixel mapping would work. Here's what it looks like with the lights on, and as I said, there wasn't a lot of space to hide this, so we have the battery in one side of the bra cup and the controller in this side, and rather than having more bulk in the lower half, that would have interfered with the performance, so there are wires that run between these two pieces that have a detachable connector, and it would be covered with tape during the performance. And for the trick that she did at the end, pulling the light out, I made a couple different types of these individual LEDs and coin cell holders so she could see what worked best during rehearsal. If you would like to see a video of the performance, I will put a link for that in the comments for this video. And if you have any questions, please put them in the YouTube comments, or you can email me directly through my contact info is at enlighted.com. Thank you.